Hi students, see in this session we are going to discuss about the reactivity of metals. That means metal having that high reactive, low reactive and the moderate reactive also there, how they are arranging, how the hydrogen is placed in the metallic series, that also we are going to discuss. Then properties, that is ionic compound, how the formations of sodium chloride, formation of magnesium chloride, like that. So that is also we are going to discuss about this, and the mainly the electronic configuration also we are recalling this session. See, this is the metal reactivity series. The reactivity series, the metals arranged in the order of their decreasing activity. After that performing the displacement reaction, already we seen that experiment also. See, the reactivity or the activity series are developed like this. See, the potassium is the more reactive element than sodium, then calcium, magnesium, aluminum, then zinc. See, the zinc is a moderate reactivity ion, then lead. See, these are the highly reactive metal. Then hydrogen is placed here. After that, these are low reactive, that is the least reactive elements like copper, mercury, silver, gold, platinum. So these are the least reactive elements. Why the hydrogen is placed in the hydrogen is a non-metal, but the metal reactivity series hydrogen is placed? Because the hydrogen is a electropositive in nature. That is why, based on this, that is, they have the standard electrode potential as 0. At 298 Kelvin, you are going to learn in higher classes the standard electrode potential. What is the standard electrode potential? That is why the standard electrode potential of hydrogen is 0 volt. So hydrogen is electropositive in nature. That is why hydrogen is placed in the metal reactivity series. Below hydrogen, above hydrogen. So this above hydrogen, this is the high reactive metal. Slowly decreases, the reactivity decreases up to lead. Then after that, the hydrogen. These are very least reactive elements. Even the gold and platinum does not react with oxygen also. So these are the reactivity series of the metals. See, how do metals and non-metals react? Already we seen that metal reactivity series. Why do metals react in this manner? See, just recall that element, that is learnt about the electronic configuration of the elements. See, we learned about the noble gases. The noble gases mean the outer electrons are completely filled. That is, the outer shells are completely filled. For example, this is noble gases, and these elements are metals and these are non-metals. And the atomic number, this is the atomic number, and the electronic configuration, this is the electronic configuration. Now, the helium having the atomic number is what? Z indicates atomic number 2. The number of electrons in cell, that is the K shell, is only 2, because helium is a duplet arrangement. Hydrogen and helium is duplet form, rest of the elements are octet arrangement. Then the elements are neon. The neon is atomic number 10. Here also the outer electron is 8, completely filled. Argon, here also the outer electron is 8, completely filled. That means 2, 8, 8. So the atomic number is 18. The maximum number of possibilities is what? In octet configuration, based on the octet configuration, 8 is the maximum. So the outer electrons are completely filled. That is, the outer shells or valence cells are completely filled. So this is a noble gas. Then look at this metal. The metal having the sodium. Sodium, the atomic number is 11, 2, 8. Then the remaining 1 electron, that is valence cell, M shell having 1 electron. This is called the outer shell electron or the valence cell electron. For magnesium, the valence cell electron is 2. Then the aluminum, the valence electron is 3. That is because of the increasing the atomic number 11, 12, 13. So here also increasing the valence cell. Look at this potassium. The potassium is 19. The valence cell here also 1. Then calcium 2. So these are the metals. Then the non-metals like nitrogen having the valence cell is 5, oxygen the valence cell is 6, then fluorine the valence cell is 7, phosphorus the atomic number 15, valence cell is 5, sulfur valence cell is 6, chlorine the valence cell is 7. See, this is the valence cell electron. See here that the electron loses, that is the outermost electron, if it loses the electron from its M cell, then it is L cell now becomes the outermost cell, and this has the stable octet configuration. The nucleus of this atom still has the 11 proton. Look at this, in this 11 proton, but the electron has the become 10 only. Okay, for a sodium atom. I am telling about the sodium atom. Suppose suppose they have a net positive charge giving us a sodium cation, that is why sodium is having a positive charge 2, 8 and only 1 electron, so that they have a net positive charge. On the other hand, the chlorine, suppose formation of the chloride ion, that is sodium chloride is formed, means what happened? The chlorine have the 7 electron. Look at here, the chlorine having the 7 electron, remaining here 1 electron, here 7 electron. So joining of sharing of electron from this atom to this, what happened? Sodium having the positive charge and the chlorine having the negative charge. Simply you can write Na plus Cl minus. Now we will see how the formation is formed. See, look at this, the formation of the sodium chloride. Here the sodium, the atomic number is 11, the electronic configuration is 2, 8, 1. So the valence electron is what? 1. That is why sodium gains, that is sodium lose 1 electron to form that Na plus. This is called sodium cation or simply cation, and lost 1 electron. Look at this chlorine. Chlorine, the atomic number is 17. So the electronic configuration is 2, 8, 7. So 1 electron is gained from that sodium to form the chloride ion, or simply we call anion. So this is cation and the anion. The formation of the sodium chloride, here the 1 electron, here is 7 electron is in chlorine atom. What happened? It's sharing, that is give and take. That is sodium having 1 electron and the chlorine having 7 electrons, like that. So what happens? This gives this sharing of 1 electron to this atom. What happens? To form sodium chloride, that is Na plus and the Cl minus. They have the positive and negative charges are occur in between this metal and non-metal, and that's why they have the electrostatic forces of attraction, that is they are ionic in nature. That is why they have the electrostatic forces of attraction of sodium and the chloride ion. Similarly, in magnesium chloride, formation of magnesium chloride. Suppose the magnesium, what is the atomic number that magnesium gives? That is 2 electrons gained, that is Mg 2 plus and 2 electron. Here the magnesium atomic number is 12, so that electronic configuration is 2, 8, 2. Here the last valence electron is 2, that is why Mg 2 plus. Similarly, formation of that is joined with chlorine atom. Chlorine, what happened? The chlorine is having 1 electron is gained to form that chloride ion. Here the magnesium having 2 plus, but here in the case of sodium having only 1. So magnesium is 2. That is why 1 more chlorine atom is joined. Then only that octet is filled. So now look at this. Magnesium having 2 positive charges. That means 2 electrons. Then chlorine. 1 chlorine is this side, that having the 7 electrons, and 1 more chlorine having the 7 electrons, this. Now 1 electrons gains to the this chlorine atom, and another 1 electrons gains to the, that is gives to the this chlorine atom to form magnesium chloride, that is MgCl2. That's why they have +2 and this having the -2 charge. So MgCl2 is formed. This is also having the positive and negative charge. That is why this is also the ionic compound in nature. This is formation of sodium chloride and the magnesium chloride. See some properties of ionic compound. Look at this, the sodium chloride, lithium melting point and the boiling point of the substance. So this is the ionic compound, sodium chloride, lithium chloride, calcium chloride, calcium oxide and the magnesium chloride. See they have the melting point, sodium chloride having the melting point is 1074 Kelvin, lithium chloride is 887 Kelvin, calcium chloride 1045 Kelvin, calcium oxide is 2850 Kelvin and magnesium chloride is 981 Kelvin. Then the boiling point of sodium chloride is 1686 Kelvin, lithium chloride having the boiling point is 1600 Kelvin, calcium chloride is 1900 Kelvin, calcium oxide having 3120 Kelvin and the magnesium chloride having the 1685 Kelvin. See the physical nature, usually the ionic compounds are solid and are somewhat hard because of the strong forces of attraction between the positive and the negative ion. So these compounds usually generally the brittle and the break into the pieces when the pressure is applied. Then the melting point and the boiling point is given like this, that is the ionic compound having the high melting and the high boiling point because of the considerable amount of energy is required to break the strong interionic attractions. That is why they have the high melting and the boiling point. Then the solubility, usually the solubility, the electrovalent compounds are soluble in water and insoluble in solvents like kerosene, petrol, like organic solvent. They are insoluble in organic solvent. Then conduction of the electricity. They are conduct electricity when in molten state or in the aqueous form of the solution, they conduct electricity. When in a solid form of this substance, they won't conduct electricity because the solid form is no free electrons are present. In molten state or in the aqueous state, the free electrons are available. So that's why they conduct electricity, heat and electricity. So these are the properties of the ionic compound. Next class we will discuss the extractions of metals, that is occurrence of metals and the extractions of metals. See, today we seen high reactive elements, low reactive elements and the moderate reactive elements. The high reactive elements what potassium, sodium, so these are the high reactive elements. Then the moderate reactive elements like zinc, then the copper, these are the moderate reactive elements. Then the low reactive, least reactive element is gold, silver. So these are the least reactive element. And hydrogen, why the hydrogen is placed in the metal reactivity series, that also we were discussed. Then the properties of the ionic compounds also we were seen, that is the formations of sodium chloride, how they form, then how the form of magnesium chloride, that also we were seen.